there are two foundational concepts that essentially underlie why we need statistics and how to use them. And so that is variance and error. And so here's a very good example of some error in the use of statistics. As my hobby extrapolating, so as you can see, by late next month, you'll have over 4 dozen husbands. Better get a bulk rate on wedding cake. And that's just because he's extrapolated from yesterday to today, from 0 to 1, and continued that trajectory upwards. But that's not quite how we need to use that information now, is it? So let's start with talking about variance. So variance basically means how things vary. And so there is what is called the measurement issue. And essentially, whenever we're trying to learn anything scientifically, we have to measure them. And so measuring, though, is not always easy. Accuracy is always an issue. It doesn't matter what you're measuring. But I mean, you think about within the social sciences, the types of things we're measuring are things like, maybe we're doing something like criminal convictions. And so, well, we just count how many criminal convictions. But then, do we want to know their official history, or do we also include, maybe something that they've admitted to that they were never officially charged for? And how do we count, if one incident had 3 different crimes in it, are we counting that as 1, or are we counting that as 3? So things like that about how we define things, that's a big part of kind of this issue. But also, accuracy is always a problem. I mean, think about how you measure something like anger or just criminality in general. Even just in terms of how we measure crime rates or how much crime is happening. Well, are we using official crime statistics? Are we using victimization surveys? Are we using self-report surveys of criminal activity? So there's always problems with how we measure something. And even if we're trying to be as exact as possible, accuracy is always an issue. So this kind of begs the question, well, okay, so if we have a decent measure, we have, we're using something that has a lot of backing, like if we want to use a personality inventory like the MMPI, that's been used a lot. It has a lot of support behind it, research support. So assuming we have a reasonable amount of measurement accuracy, big assumption, but assuming we do, it's often impossible to get the same measurement twice, even when the 2 measures are actually the same. So what this means is that if you're measuring the same thing twice, you don't always get exactly the same measurement, even if it's the same thing and nothing has changed. And so there's going to be variability or variance, even sort of within the measure of any one thing. You measure, the height of something, or, the length of a room. You're going to maybe get a little bit different every time, maybe just off by like a hair, like a millimeter or 2, but it's going to be a little bit different. Even something like measures of personality profiles, anger problems, measures of social or economic deprivation. Even the same person in the same situation is going to get at least slightly different results if those things are measured twice. So something that appears to be a constant or appears to be different may actually not be. And so, for example, you have 2 different people scoring the same on, let's say, the personality inventory, like the MMPI, the Minnesota Multifaceted Personality Inventory. It's used for diagnosis and treatment of various different personality disorders, other psychological issues. So you have 2 different people who get the same score, because there's only so many scores. There's only so many numbers you can get. So, but they don't actually have the same personality, or maybe they don't even have the same problems. They've just scored the same on this personality inventory. So you can have something that appears to be a constant, but it actually isn't. And you can also have something the opposite, where it appears to be different, but it isn't. So if the same person scores differently at 2 different times that they take the same inventory, because maybe they answered 1 or 2 questions a little bit different because it was affected by their mood. So there's no significant change in their life or really sort of how they're feeling or their psychological profile, but there'll be a slightly different final number. So sometimes you have these things where, well, it looks like a constant, but maybe it's not, or it looks different, but maybe it's not. And so that's why we have to measure variance. We have to see, basically, is there real variance going on? So the reasons we have variance then, one of the reasons that we have variance is because there's inaccuracy in how we measure things, or error. And so this is one reason that there will be variance. And so things are going to change, again, not because of anything that's happening or any inherent differences that we're actually trying to tap into. It's just error, measurement inaccuracy. So that's going to cause variance. But, of course, real differences are also going to cause variance. If, the things that we're actually hoping to tap into, if they're there. So if there are real differences, let's say if we're comparing groups on some kind of measure, we want to tap into the actual real differences. That's what we're interested in. That's the whole point of doing these comparisons, is to see if there's differences there. But we want to make sure those are real differences and not just differences because of measurement inaccuracy or error. So that's kind of why we'll see variance, we'll see differences and changes within any type of data. And so then that means that sort of equates to two different types of variance. So we have real variance, that variance that we're actually interested in. We want to see if there's differences between our two groups, or between time 1 and time 2 with some kind of intervention in between, or whatever. It's the real differences that we're actually interested in. Versus error variance, which is what we hope to reduce as much as possible. And so error variance is still variance. It's still going to be differences between scores or differences on our measures, but it's not real. And it doesn't mean anything. It's just error. And so if we can reduce that as much as possible, or at least account for it if we know that it's there, then we can kind of parse out what's real and what's error. And then the real stuff is what we really want to focus on. And that's kind of what we can do when we're using variance within statistics.